Okay, welcome to Level 1 Science Online with Henny van Vieren.
Hi Year 11s, welcome to our first online lesson, and today we're going to be talking specifically about average speed. We've done some work on this already in class, but I think it's not a bad idea if we recap some of that. Okay, so off to the presentation. So remember we talked about motion, and we said motion is the movement from one point to another, and how if you go from point A to point B, you have your initial distance and your final distance. Remember that? And speed is the time that it takes you to travel that distance. So we take distance over time is equal to speed. Just like distance is a kilometer divided by time is an hour. Kilometer per hour. Kilometer per hour. That's how it works. Meters per second. It's always the distance over the time. And when we calculate the change in distance, you take your final place where you stopped, then you subtract the beginning place where you started. So it's called distance final minus distance initial, and that gives you the change in distance. And the same thing with time. If you, for instance, only wanted to measure from where the back wheel is at the moment up to B, you're going to say your time initial, it could be 2 seconds, and time final could be 5 seconds. So you take 5 minus 2, that would give you your change in time, which is 3. Okay, but we'll look in a little bit more detail. So here's the formula. It is velocity, which is meters divided by seconds, meters per second. Okay, meters, remember, is the distance and second is the time. So we use the formula velocity equals d over t, distance over time. Now in all assessments you will be getting these things, so don't worry about that too much. If you want to remember your triangle, if something is already above the line like it is here, then you put it above the line in your triangle. And then the one on the left comes on the left and the one on the right comes on the right. And when you want to calculate what velocity is, then you take the other two. You say v equals d over t. When you want to calculate time, you say time equals d over distance over velocity. When you want to calculate distance, you say velocity multiplied by time. Okay, so this is a screenshot of the 2017 paper, I'm sorry, and you will see there's your velocity equals change in distance over change in time. Can you see that it's already above the line? So when you're going to draw your triangle, let's try this. When you draw your triangle, you're going to go basically like that, saying that D is already above the line, and then the other two will sit like that. Okay, so delta D over delta T equals V. Remember I told you the triangle is called delta. Delta simply means change in distance over change in time. And you'll see all these others we're going to use later. Okay, there's acceleration, there's force, your net force, and so forth. So, again, to calculate the distance, you can use this formula for various, to calculate velocity, you can use the formula to calculate distance, you can use the formula to calculate time. Okay, sometimes when you don't use velocity but speed, remember velocity has a direction in it as well, then you can use speed, which is just a moment in time, or it's not as accurate as velocity. So if we want to calculate for instance the distance, so we take distance, and you can see if we take the distance, we put it in front of the equals, then it's going to be velocity times time, velocity times time. If you want to calculate velocity, it's going to be d over t. So v is d over t. And lastly, if you want to calculate time, time is d over v, distance over velocity. And that's how you're going to use all your triangles if you want to use triangles. Okay, there's another way. You just cover it. So here you can see we want time, so we cover it with our hand. Distance divided by speed. Cover speed, you have distance divided by time, and if you cover distance, you have time times speed gives you the distance. So, what is average speed? Average speed is when you take your total distance that you traveled and you divide it by the total distance that the time took, will give you an average speed. But when I say total, it can actually sometimes be a little bit misleading, because you can say, what was my average speed in the middle of my trip? So then you take the change in distance in that area that you want to measure, and you divide that by the change in time. So average speed or velocity that has been that is the speed that has been traveled on average over the entire distance. Okay, when you look at a car, if you're driving in a car and actually just look at your speed indicator, that's your instantaneous speed. Just because you go 100 kilometers an hour in some areas doesn't mean that the whole thing is going to be 100 kilometers an hour. Okay, so if you travel from Cambridge to Hamilton, for instance, 70 kilometers an hour, but they might be traveling some areas at 100 kilometers an hour, and so forth. So your average speed is delta d, or change in distance over change in time. I've said that so many times now. Okay, so this was question 1A in 2015, all about motion, and it was the diver. Okay, so Chris and Ian. There's Chris and Ian. Don't know which is which. We'll figure it out. Chris and Ian were jumping off different platforms into a pool. It took Chris 0.6 of a second, there's your time, to reach the water, once he had jumped from the platform that is 2 meters high. So that's your distance. Distance is 2, time is 60. Calculate his average speed. Distance over time. The reason why they say average speed is, remember, when he starts to jump, he's not traveling at his maximum speed. His maximum speed is going to be reached once he hits the water. Oh, I see, I'm pointing to the wrong guy because this one is 5 meters. So here we go. This is Chris. Chris takes 0.6 seconds to jump in there. And this question was for achieved, so you simply take your distance and you put it over your time. Always remember to show your working, guys. Show your steps. If you don't show your steps, the examiner don't know where you're coming from, and consequently it's easier for you to lose your marks. So velocity is distance over time, so you take the distance, which was 2 meters, you should have written meter there, divided it by 6.6 seconds, and then a meter over a second becomes meters per second. That was 3.3. Okay, so for that, I need you to please complete in the SciPad pages 8 to 12. But before you go on to that, we are also going to look at some distance time graphs. Now, you have done graphs in the past, and you know that we always have rise over run. When you run, it's a flat, the x-axis, and rise is the up and down, which is the y-axis. Okay, and if you look at this, the rise over run, distance over time. Distance over time. What will that give you? It gives you velocity, because it's distance over time. So if you wanted to, with a graph, calculate how fast this person was going between time 1 and time 2 seconds, you can say if student B was at literally at half a meter at 1 second, and at 2 he was at 1, then we take the final distance minus the initial distance. So in this case the final distance is 1 and the initial distance is 0.5. We subtract the 2, that gives us a distance from there to there of 0.5 meters as well, and the seconds. So we take the final time and we subtract the initial time. So that's 2 minus 1 gives us 1. So it's going to be 0.5 over 1, which is going to be 0.5 meters over second, or meters per second. Okay, so that is a distance time graph. So they can give you a graph and ask you to calculate the average speed or the instantaneous speed or the average velocity or the instantaneous velocity. Now the steeper the line in a distance speed graph, now whether it's a curved line or not, the steeper the line, the faster it goes, because you are traveling a further distance over a shorter time if you are very steep. So in this case, if we go and we say 0.5 a second and we go all the way from there down to 0, that was a very short time for a very far distance in comparison to student B. I hope that makes sense. So distance time, so when we have different views of the same thing, a very steep line, but it's a straight line, is always, that's a fast velocity, but it's a constant velocity. Can you see that it's, as time ticks on, the distance will tick on as well. So that is a constant velocity. This initial part here is also constant because it's not curved, but look here, this is curving. So as time goes on, it becomes quicker and quicker and quicker and quicker. That is called acceleration. And remember, when you flip this over, it could have gone, time goes on and it goes slower and slower and slower and slower. That is deceleration. So by looking at the curve of a distance time graph, you can see if it is accelerating or decelerating, if it's a constant speed. Now look at this one. Distance doesn't change. So if somebody is 5 meters away from you and they're staying there for a minute, the time is going to still run, but they won't change. They will still be 5 meters away. If with Corona you keep somebody 2 meters away from you and both of you are standing still, it means that they didn't move. Okay, so the distance is going to remain the same. As the time moves on, that means they are stationary. And over here, they are doing a constant speed, but it's coming downwards. So what's happening? If this was 2 meters and it's going down to 0, it means they're coming towards you. Okay? So it simply means coming towards you. Your distance is getting smaller. Over here, it's going away. The distance is getting more. So this car or this thing that moved went away for a certain distance, stopped there for a certain time, and then came back at a constant speed. Alrighty. Okay, so we would have loved to done some experiments with you where we roll marbles down a ramp or we do toy cars down a ramp, and then we collect the data. Unfortunately, we're just going to have to do some bookwork for now. So yeah. So again, a distance time graph can be used to calculate the velocity. So I've said this many times now. So your distance over your time. Please read through this slide. I talked about T2 and T1 as in final time versus initial time. How to do final distance versus initial distance. Okay, and then for today, so I need you to take SciPad pages 13 to 17 and 8 to 12. So basically 8 to 17. Can you please work on those to make sure that all this information stays in your brain? Alright, thank you guys, thanks for your attention, and please stay safe and stay healthy out there. Thanks, bye.